Welcome to the video on kinematics. First, we'll talk about kinematic derivatives. So the derivative of displacement, or S, is velocity, v. So v equals ds dt. So if you take the derivative of your position with respect to time, so your change in position over your change in time, that's your velocity. The derivative of your velocity, v, is acceleration, a. So a equals dv dt. So your change in velocity over your change in time. And it's also your second derivative of your position. So if your displacement function was t squared minus 5t plus 7, then your velocity would be the derivative of that, which would be 2t minus 5, and your acceleration would be the derivative of that, which would just be 2. For kinematic integrals, we have the integral of velocity as displacement. So if you want to know your displacement from one time to another, it would be the integral from the initial time to the final time of your velocity. If you want to know the distance between two times, it would be the integral from the initial time to the final time of the absolute value of the velocity, because your speed is the magnitude of your velocity. So if your velocity function, for example, was 3t squared minus 2, and we wanted to know the displacement between t equals 0 and t equals 5, you would do the integral from 0 to 5 of 3t squared minus 2 dt. So that would be t cubed times 3 over 3, so 1t cubed minus 2 times t evaluated from 0 to 5. So you would plug in 5, and then you would subtract that with 0 plugged in. So this would be 125 minus 10 minus 0. So that would be 115. And this is displacement, so it would just be units, whatever units you used for distance. So this is displacement. If you wanted to know the distance between, that would equal your integral from 0 to 5 of the absolute value of 3t squared minus 2 dt. So we could look at our function on the inside, our 3t squared minus 2, and we want to find when that's greater than or equal to 0. So 3t squared is greater than or equal to 2, so t squared is greater than or equal to 2/3. So t is positive, greater than 0, if it's greater than or equal to the square root of 2/3, or if it's less than or equal to negative square root of 2/3. So our function would look something like this. And this is root 2 over 3 and negative root 2 over 3. So we're looking from when t is 0 to 5 for our function, and our velocity is negative from 0 to square root 2 over 3. So we'll need to do our negative velocity function. So our integral from 0 to square root 2 over 3 of negative 3t squared minus 2 dt plus our integral from square root 2 over 3 to 5 of our normal velocity function, 3t squared minus 2 dt. So this is the integral from 0 to root 2 over 3 of negative 3t squared plus 2 dt plus the integral from root 2 over 3 to 5 of 3t squared minus 2 dt. So this would be negative t cubed plus 2t evaluated from 0 to root 2 over 3 plus t cubed minus 2t evaluated from root 2 over 3 to 5. So you would have negative root 2 over 3 cubed plus 2 times root 2 over 3 minus 0 plus 5 cubed minus 2 times 5 minus root 2 over 3 cubed minus 2 times root 2 over 3. So this would equal approximately 117.18 units. So our displacement is less than the total distance traveled because your velocity started out negative and then it switched to positive. So the object moved to the left, then the right. So the total displacement was less than the total distance traveled. So here we have our first IB practice question. It says a kid drops a coin from a tall building. The path the coin travels is modeled by the equation S of t equals 828 minus 9.8 t squared, where S is in meters from the ground and t is time in seconds. A, find the equation for the velocity of the coin with respect to time. So our velocity is the derivative of our position. So our position is this equation. So the derivative of that is velocity. The derivative of our constant is 0. And then we have negative 9.8 times 2, which would give us negative 19.6 t. So that's our velocity equation. Part B says write the equation for the acceleration of the coin with respect to time. So the acceleration is the derivative of velocity. So that would just be negative 19.6. Part C says what's the speed of the coin after 5 seconds? So speed is the absolute value of the velocity. So that's going to be the absolute value of negative 19.6 times 5, which equals 98. And the units for our velocity would be meters per second. So it would be 98 meters per second. Part D says, what's the speed of the coin when it hits the ground? So the coin will hit the ground when the position is 0 because S is meters from the ground. So the coin will hit the ground when 0 equals 828 minus 9.8 t squared. So 9.8 t squared equals 828. Then you divide by 9.8 to get that t squared equals approximately 84.49. Then we can take the square root of both sides to get that t equals approximately 9.19 seconds. It would be plus or minus, but you don't have negative time, so that's why we just use our positive value here. So it's going to hit the ground after that much time, so we want to know the speed when it hits the ground. So we'll do the absolute value of v of t when t is 9.19. So you'd have the absolute value of negative 19.6 times 9.19, which equals approximately 180.12. And this is speed, so it's meters per second. So that would be going really fast by the time it hits the ground. So here we have our second IB practice question. It says the velocity of a train is given by the function v of t equals 3t squared minus 12. Find the train's displacement from t equals 0 to t equals 5. Then find the train's total distance traveled over that same time interval. So our displacement is the integral from t1 to t2 of v of t dt. So our displacement will equal the integral from 0 to 5 of 3t squared minus 12 dt. So this equals t cubed minus 12t evaluated from 0 to 5. So that's 5 cubed minus 12 times 5 minus 0 cubed minus 12 times 0. This whole second part equals 0. So we have 125 minus 60, which equals 65. And we don't know the units because it doesn't say it in the problem, so you would just say 65 units. So the train's displacement is 65 units. Now we want to find the distance traveled. So our distance traveled is going to equal the integral from t1 to t2 of the absolute value of v of t dt. So we need to start by finding when our velocity is positive and when it's negative. So we'll find when it's positive by saying 3t squared minus 12 is greater than 0. So 3t squared is greater than 12. So t squared is greater than 4. So t can be greater than 2, or t can be less than negative 2 for it to be positive. So in between those values, it's negative. So our function would look something like this, where we have negative 2 and 2, and between those values, our function is negative. So in our window, from 0 to 5, we need to separate it and use negative v of t from 0 to 2. So it's going to equal the integral from 0 to 2 of negative 3t squared minus 12 dt plus the integral from 2 to 5 of 3t squared minus 12 dt. So this equals the integral from 0 to 2 of negative 3t squared plus 12 dt plus the integral from 2 to 5 of 3t squared minus 12 dt. So we have negative t cubed plus 12t evaluated from 0 to 2 plus t cubed minus 12t evaluated from 2 to 5. So this will equal negative 2 cubed plus 12 times 2 minus negative 0 cubed plus 12 times 0, which all equals 0, plus 5 cubed minus 12 times 5 minus 2 cubed minus 12 times 2. So this equals negative 8 plus 24 plus 125 minus 60 minus 8 plus 24. So the total distance the train travels is 97 units. The train's distance traveled is 97 units. So what that means is that the train traveled in the opposite direction for some amount of time, and then in the forward defined direction. So the total distance traveled this way and then this way is 97 units, but the total displacement from the original location is 65 units. So in summary, the derivative of displacement is velocity. The derivative of velocity is acceleration. The integral of velocity is displacement. So your displacement over time is the integral from the original time to the final time of the velocity, and the distance traveled from the original time to the final time is the integral of the original time to the final time of the absolute value of velocity, because speed is the magnitude of your velocity. That's all for this video. Thank you for watching.